In this lecture, we're going to start talking about integration by parts. Before we begin talking about integration by parts, we need to review the product rule. If f and g are differentiable functions, then we can differentiate the product of these two functions using the product rule formula. The derivative of the product of f and g is the derivative of f times g plus f times the derivative of g. For example, if we want to differentiate the product of t and log t, then it's the derivative of t to the 1 power, which is 1 times log t, plus t times the derivative of natural log, which is 1 over t. If we do a little algebraic simplification, we get that the derivative of t times log t is the natural log of t plus 1. If we continue practicing using the product rule, let's differentiate x times e to the x. Well, the derivative of x times e to the x would be the derivative of x, which is 1, times e to the x, plus x times the derivative of e to the x. And remember, e to the x is that function whose derivative is itself. If we simplify algebraically, we can factor the e to the x, and we get the quantity 1 plus x times e to the x. More interestingly, that means we can integrate both sides. On the left-hand side, we have the integral of the derivative of e to the x times x. And remember, if we use the fundamental theorem of calculus, the integral of the derivative of x e to the x would just be x e to the x. Now, I realize this is plus a constant, but we have an indefinite integral on the right-hand side, and that will have a constant too, and we only need one. On the right-hand side, we have the integral of the quantity 1 plus x times e to the x dx. So it would seem that if we can use the product rule to differentiate the product of two functions, then we ought to be able to use the product rule in reverse to integrate the product of two functions. Let's continue working in that vein. We can differentiate x times natural log of x and get the natural log of x plus 1. This is the exercise we did on the first slide. But that means that if we integrate the derivative of x times log x, we should get, in the third line, x times log x. But when we integrate the right-hand side, we get the integral of the natural log of x plus 1. And remember that the integral of the sum is the sum of the integrals, so we get the integral of natural log x dx plus the integral of 1 dx. Well, we know the integral of 1 dx, its antiderivative is x plus c. If we subtract x from both sides, we get x times the natural log of x minus x is equal to the integral of the natural log of x dx. And we have discovered something important, the integral of the natural log. We know that natural log's derivative is 1 over x, and now we know its antiderivative. This gives us the integration by parts formula. How do we integrate the product of u and v prime dv, or just dv? We identify the two factors in the integrand, u and dv. We compute the derivative of u, that is, we compute du. We compute the antiderivative of dv, that is, v, and we use the integration by parts formula. That is, we use the product rule in reverse. Let's look at an example. Let's find the integral of the product x e to the x dx using integration by parts and checking the results. Okay, to integrate a product like x e to the x, first we have to identify each part. We need to identify something easy to differentiate. This will be our u. And something easy to integrate. This will be our dv, like e to the x dx. And we should make a note of it. So what we usually do is make a note. Let's see here, u is x, and dv is e to the x dx. So, next step, differentiate. We will differentiate implicitly, just like we did when performing substitution. So du dx, we'll compute du equals 1 dx And if we integrate both sides of dv equals e to the x dx, then we get, well, the integral of dv is v equal, and the antiderivative of e to the x dx is just e to the x. And so now we know that. And now we know that the integral of x times e to the x dx is going to be u x times v e to the x minus the integral of v e to the x du. Now remember that when we differentiated a product of two functions, we had to differentiate twice, and we got a sum. So if we're going to integrate a product of two functions, we're going to have to integrate twice. And we'll get a difference. Well, the first term is done. When we integrate the second term, we get the integral of e to the x dx. We know what that is. It's e to the x plus a constant. It doesn't matter whether we have plus c or minus c because it's an arbitrary constant. And we have discovered the antiderivative of the product x e to the x. Now to check it, of course, we're going to differentiate it. So let's do that. Let's take a copy of it. And let's bring it down here and differentiate it. Well, the derivative with respect to x of this sum will be the derivative with respect to x of x e to the x minus the derivative of e to the x, which is just e to the x, plus the derivative of a constant. Well, the derivative of a constant is 0. To differentiate this first term, however, we're going to have to use the product rule. This will always occur. We'll need the derivative of the first factor times the second plus the first times the derivative of the second plus 0. Notice that these two terms will add up to 0, leaving us with the product x times e to the x, which was our integrand. Let's try a second example. Let's integrate the product of x times the natural log of x dx. Well, in this case, the easy thing to differentiate is natural log because we don't necessarily know how to integrate it easily. So let's call the natural log of x here our u because it's something easy to differentiate, as opposed to our dv, which is going to be x times dx, because it's something easy to integrate. Polynomials are relatively easy to integrate. And so we note that u is the natural log, while dv is x times dx. So let's calculate the derivative of u. So we get du equal 1 over x times dx. And let's integrate dv and get that v is x squared over 2. And so it turns out that the integral of x times the natural log of x dx is going to be the log of x times x squared over 2. We'll go ahead and write it this way. Natural log of x times x squared over 2 minus the integral of v x squared over 2 times du, 1 over x dx. Well, before we integrate the term on the right, it appears that we need to simplify a little bit using algebra. X squared divided by x is just x, and so we have 1/2 of the integral of x dx. Well, we know how to integrate that. The antiderivative is x squared over 2, but we already have half of that, so we have x squared over 2 times the natural log of x, our previous left-hand term, minus 1/2 of x squared over 2, so x squared over 4, plus c. Let's check to make sure that we have the right integral or antiderivative. To do that, we're going to need to differentiate it. Let's make a little copy of it real quick. So let's differentiate x squared over 2 log x minus x squared over 4 plus c. Well, to differentiate the first term, we have a product of two functions, so we're going to have to use the product rule. The derivative of x squared over 2 times log x will be the derivative of x squared over 2. That would be 2x divided by 2 times natural log of x plus x squared divided by 2 times the derivative of natural log minus the derivative of x squared over 4. That would be 2x over 4 plus the derivative of a constant, which is 0. So we obtain x times the natural log of x. Now, the second term, we're going to have to use a little algebra. X squared divided by x is just 1x divided by 2 minus x divided by 2 plus 0. And those last two terms add out and give us 0. And so the derivative of our quantity x squared over 2 times the natural log of x minus x squared over 4 plus c is indeed our integrand x times the natural log of x. Now I'd like you to complete a similar problem. Integrate x times the natural log of the quantity 2 times x dx. Thank you.